Thanks, Dr. Barry. So the things I'm going to talk about is basically why should I even give this talk? And then I'm going to talk about geothermal investment and developing geothermal in Northern Ireland. And the things I hope that you remember when I'm done with my talk is that there's really good potential for geothermal development in Northern Ireland, and it is worth the investment. So I think that's an important point. I think one of the things you'll hear over and over, I think through my talk, is that a geothermal project really is a marathon. These things take a long time to develop, and they need a champion to get across that finish line. And I'm going to show some examples of the projects I've been involved with, and I think you'll get the sense of the scale and scope that it takes to deliver a geothermal project, regardless of where it's located. And then as Dr. Barry alluded, in the early days of a country's growth in the geothermal market, private investment really may not be enough to make a project commercially viable. So those are the three sort of talking points that I'm trying to stress in this overall talk this morning. And thanks a lot for taking the time to listen as well. So I'll talk a little bit about Arup and my background if you don't know anything about me or Arup. Basically, Arup was formed in the mid-40s in London by a guy named Ove Arup, who had these core ideas of shaping a better world and total design. And so having a consulting engineering firm that had all kinds of different skill sets that could come together to really develop a project holistically. And he's always had this concept of shaping a better world in his core philosophy, which the people that work at Arup, we've all drank that Kool-Aid and signed up to, and are sort of the things that excite us about working for a company like this. We're not the largest consulting firm in the world, but we're definitely not a small one either. We've got offices all over the world, including Belfast and other places in Ireland. We do a bunch in the world of deep geothermal and shallow geothermal. So we run the gambit on things. I mean, we're a consulting firm. If you ask us if we can do it, we'll say yes. That's not too untypical for a consulting firm, but I'll show some experience and some of our specialisms in deep geothermal. So myself, I'm American. I've been in the UK for about 9 years now. I did the first 17 years of my career in California. And academically, I have a master's degree from the University of California, and I've worked at both UC Riverside with Reem van Genoegden, and I worked at UC Berkeley before moving into the consulting world. And originally, I'm from the Washington, D.C. suburbs and went to Virginia Tech. Some of the projects that Arup has worked on, I've delivered all of these for Arup. We do a lot of work in the world of seismic hazard. Related to deep geothermal. We published in Science on it. We've worked on the projects in Cornwall, both United Downs and Eden Project. We've helped Johnson & Johnson, their subsidiary Janssen Pharmaceutical that developed one of the COVID vaccines. We've helped them develop their geothermal project in Belgium. We've worked in Finland and Sweden, all in the area of seismic hazard assessment. We've also done a lot of work in the realm of transaction support and advice. We helped Macquarie invest 1.2 billion in the Philippines company EDC, which is the biggest geothermal company in the world. So we have a lot of experience in the investment sphere, as well as also participating in the delivery and technical delivery of projects. We do a lot of work in other areas too, including land contamination, shallow ground energy and ground source heat pumps, and a lot of basic groundwater type of work. So now I'll get on to the meat of it, and I'll talk about the work that we did for the Renewable Energy Association and what the findings of that work is. So the basically report reproduced in May. And as I'm going through this, I'll talk a bit about this report, and then I'm going to talk more generally about developing opportunities and the challenges that you may face developing a project in Northern Ireland. Just to be clear, we're on this side over here. We're talking about the deep geothermal stuff. That's the focus of this. Everybody likes to throw the word geothermal around. It's a fun word. We see a lot of people get excited about it. We see people who are like bored with solar and bored with wind and come to us and say, I want to do geothermal. And then we have to figure out exactly what kind of geothermal they want to do. So, but today we're talking about the deep stuff. So a deep geothermal reservoir, we're trying to produce heat and power from it. And we're drilling some serious wells to get down into those reservoirs. So why would we think about geothermal? You know, you look at this chart here at the right, and you see all the stuff, wind and solar and many, large scale hydro dams and mini hydro dams. You can see the development profiles as a function of time in the UK, and basically geothermal has just always been down here. You know, it's never really taken off. It's never really gone anywhere. Other stuff, wind and solar, they've done well and taken off and developed in the UK, but it's an untapped fruit, geothermal in the UK. And there's a massive heat demand all over the UK. I mean, you know, I don't know what it's like in Belfast today. In London, I'm from California. I have a sweater on. I have a sweater on most of the time in the summer, at least. And we've got a massive heat demand in the UK. So there's a lot of opportunity to generate heat. And there's a lot of people that can utilize that heat if we can provide it to them. And there is a resource down there. It's not the Philippines, it's not Turkey, it's not Indonesia, but there is a very reasonable and decent resource all over the UK, including Northern Ireland, that can be accessed. So how do we get from talking about it for decades to actually putting some deep holes in the ground to producing energy? And that's what I'll sort of lean on in this talk. Everybody wants electricity from their geothermal project. When we get people coming to talk to us, the first thing they'll say is, I want to do an electricity power plant. And then we have to talk to them about this little word called enthalpy. And we have to talk to them about the reality of what they should be considering when they develop a project in the United Kingdom, including Northern Ireland. And so this is the last equation I think I'm going to put up today. I think it's an important one because it stresses some really important concepts that we all have to keep in mind with geothermal. And we'd like to talk about enthalpy from the perspective of chemical reactions. That's where we learn about it in Chemistry 101. But it's a really good analog for the potential of a geothermal reservoir. And the enthalpy itself, the H, is basically the geothermal potential. The E is the internal energy that is part of the reaction, and that's really, you can consider that to be the temperature. The volume is how big is your reservoir, and the pressure is what's coming out of the reservoir and the well yield. So really, when you look at it, it stresses three important parts of the enthalpy, and that it's not just the temperature, but it's also what comes out of the well and how fast you can produce it from the well. So it's two real important points. It's the temperature and the yield. And the thing you have to remember is as you go deeper into the ground, you're going to be sitting underneath more and more weight of the overlying rocks. And so as you go deeper, the rocks get denser and tighter typically. And so they typically become less permeable. So you might want to you might think, oh, I'll just drill a little bit deeper. And as I go deeper, my temperature will go up. But you have to deal with the fact that your permeability may be going down, or it may be trickier to find the good spots in terms of permeability, because once we get that deep, we're not looking for flow necessarily in the rock per se, but we're looking at the cracks and where the discontinuities are so that we can extract these fluids to run through our systems. So in a country and an area where we don't have a lot of plants that are sitting around producing energy already, we're going to be dealing with a very massive investment hurdle to get over. And for that reason, going for heat is a very reasonable target, because heat is a lot more accessible in the United Kingdom than power. And so when you consider a project and you consider what your target is, you have to be somewhat flexible about what you're trying to deliver. And that has a lot of knock-on effects when you're developing your opportunity. So as Dr. Berry pointed out, we've done a report. We based that report on a bunch of assumptions, and those assumptions lead us to the ability to develop geothermal projects on a large scale across the entire United Kingdom. And if that happens and things go great, we will do a lot to decarbonize our energy needs in this country. And that would be a fabulous story that everybody wants to happen. Nobody wants to not develop low carbon technologies. They may think it's ridiculous or difficult or tricky or whatever, but we all want to get there to some extent. And to develop geothermal would be a great thing for the United Kingdom. And that would be a great thing, both in terms of the amount of carbon offsets that are realized from developing geothermal, to the ability to generate a base load source of energy, whereas we all know that solar needs it to be a bit sunny and wind needs it to be a bit windy, but geothermal can just keep chugging along producing low carbon renewable energy. And we'd also generate jobs, and we'd also be able to transition all of these great oil and gas engineers into something that is a renewable energy industry. So how did we come up with this sort of nonsense of these curves? We basically looked at how the industry exists in the UK, what the geologic potential is in the UK, what the historic growth is, which is non-existent, obviously, and what the growth was globally. And we looked at how that global growth was successful and what pushed growth in other countries. And really what it comes down to is government support. And that is the main theme to kickstart the geothermal industry successfully across the globe, whether you're in Europe or Asia. It may be the United States is the only real exception to that, because they started a lot earlier than most other places, and they had some real accessible geothermal reservoirs to tap into. So we looked at all of these different factors. We integrated those into some very simple calculations, and that's how we basically came up with our charts. Our report goes more into that, and obviously I'm happy to talk about those sorts of things and the basis for those things. And the real reality is we wrote a report with the goal of exciting the UK government that this is something they need to pay attention to. And this has a definable and quantitative benefit to the UK overall. And it's something that they should be really seriously looking at and really taking seriously the government's role to stimulate the development of geothermal. The success story, it's really clear. The Philippines, when you contrast Indonesia with the Philippines and the role of government between those two countries, you see that the Philippines just jump-started their geothermal industry. And that jumpstart was a direct relationship to the Philippines government developing geothermal drilling in that country. Kenya and Ethiopia is another great example where Kenya took it seriously. They invested in geothermal drilling. In Kenya, I think they produce about 50% of their electricity from geothermal per capita in that country. Turkey is also another great example that's is very successful in geothermal development. And then in Europe, you see the Netherlands and Germany has had government programs in place and has developed their geothermal market significantly compared to other countries. Now, that gets us to the point of what should we recommend to the government? So what should we recommend to the government, and how should we recommend that they develop it? Governments have a lot of agendas, and there's a lot of different people involved in government and looking at things from different perspectives. I I think that we chose to keep it simple. We wanted to give them just a very simple couple of ideas to really get the ball rolling for them to develop their own thinking on it. And so we could have given them a lot of different options for developing this, or we could have given them a few, and we chose to keep it simple because we think that that may be a bigger, have a bigger impact and create momentum in a government to develop this. And so that's basically how we got to. And we came up with a concept of a geothermal development incentive, which basically generates a tariff that is advantageous for a geothermal developer. So it gives them a better cost to produce heat and revenue stream, but it's only, the government's only paying for this for projects that are actually producing heat. And so that gave two sides of the coin, which we thought would be beneficial to the industry. And that is zero risk to the taxpayer. So they're not investing in things that would not be successful. So different from places like Kenya and the Philippines, where they directly invested in drilling. And it also would produce a assurance to investors for geothermal projects of the cost of the heat that they would be selling. So I'll get a bit into the private investment perspective in a little bit, but basically we thought that that would be a very simple way for the government to manage risk and also get behind something that would provide something very concrete and tangible to geothermal investors. So the bottom line of our study is something that Dr. Berry discussed at the beginning, and which I've been talking about, is that geothermal needs help. It will have a good impact for the country if we can develop it. We've developed or produced a recommendation that's low risk to the government. It costs something, obviously. It's not free for the government, but at least there's no risk. It would only be utilized for successful projects. And I think the underlying line is that without this support, we're almost certain to see the same lack of growth in the industry. So now, you know, we had this title that I came up with the guys that asked me to do this talk, Joe Ireland and folks, and it's basically, what does becoming geothermal ready really mean? So what does it mean? And you know, that's sort of a concept I think that I can play out throughout this sort of talk. And you know, does it mean that you have like this amazing geothermal potential in the ground that just needs to be tapped to, and geologists are super excited and studying it and talking all about it, and that's what we love, and that's why we're in this industry in the first place? Does it mean that it's got these amazing geothermal governmental regulations all set up, super easy to follow, and you just go ABC forms and you're there and you've got a permit to develop geothermal? Does it mean that we've got steel pipe just waiting around and turbines just collecting dust that need to be plugged into systems? And does it mean that we have experienced drillers that are just like, yeah, no problem, I will never have a problem, and the quote that I give you for this project is exactly how much it's going to cost? Is this what it means? I don't think it means any of that. I think it means I think what being geothermal means is having serious investment ready to spend on a project. And that's what I'm going to focus on for the rest of the talk, is my experience from the sidelines of watching that investment come into place. I think to some extent, having these things helps, but the real proof in the pudding is having somebody ready to spend money on a project. Okay, so how do you do it? How do you get this money? And we talked a lot about government support already because our experience is that it's needed. I'm going to talk about private investment, and that includes the crowd. I'm not going to talk about who's spending the money on the project. I'm going to talk about how do you get them to spend the money on the project, which is what you can control. And between the government and between private investment, it's two different stories. The government wants to know, how is it going to benefit me as a politician to be reelected? That's really what it comes down to. So what's the story? And the story is jobs and low carbon development. And how do you sell that and prove to the politicians that are going to enact this government support that that's the story that they get to tell when they've invested in this, at a national scale. So, but I'll talk about private investment now. And private investment is really about this colorful little picture here. And it's about how you communicate the risk and the reward for a project. And what you can see here at the bottom is the bankability of a project. When are you getting a bank involved for financing a project? And what you can see is at the beginning, a bank is going to ignore you, and they will start to listen at a certain spot, and they'll be available to give you a loan. So you've got this massive part of your project early on where the banks are pretty much just don't want to talk to you. And that's the part that you have to get through to get the banks to start to listen. And the irony, the tragedy of geothermal, however you want to say it, is that until you get that first well into the ground and you prove the resource, banks don't really want to pay that much attention. So the geology is obviously very important. Understanding the geology, being able to de-risk the geology, but getting that initial investment to pay for the well is really a critical part of your game to get this project developed. And so that really relates to the other two bullets on this slide, which is the end user and the financial model. Investors want to know they have a customer to sell to, that when this plant is switched on, when you flip that switch, you're selling your energy from day one. And that's a big part of it. And we'll talk a little bit about that. And we'll also talk about the financial model and what investors will be challenging you on in your financial model. But really, when you look at this risk profile and the CapEx, about half of your CapEx is going to be in drilling, and about half of your CapEx is going to be in the plant. And if it's a heat plant, more of your CapEx is going to be for the drilling. And if it's a electricity plant, if you're lucky, less of your, it may be about 50-50 between the turbine and the balance of plant and the wells. So you got to get through this thing to develop your project. And the geology, as I said before, it comes down to two parts: the heat. That's pretty much the easy part. The BGS has done a great job. The Geologic Society of Ireland, Northern Ireland, they've all done great jobs of evaluating the thermal balance across Northern Ireland. And there's a lot of good information out there. And I certainly don't need to produce that, because there's lots of geologists that are very excited about it that can dive into that bit. So we generally understand where the heat is and how far down you have to go. And you're not going to be in a situation where it's no heat or amazing heat. It's going to be how close are you to what the maps tell you, sort of sensitivity when it comes to the heat. It's the flow. That's the real challenge. The good news is that Northern Ireland has some really productive geologic formations. There's good sandstones in Northern Ireland that are relatively deep. There's good fractures out there. So heat is accessible in Northern Ireland. That's the real story, and the real good news story for Northern Ireland is that the heat is accessible. And there may be some electricity there too. I mean, I think we need to do more work and more drilling to really know the answer to that. But the heat is definitely accessible. So that's the good news story about the geothermal. But remember, the banks aren't listening yet because you haven't drilled a well. So you still need to get cash in place to deal with this part of the curve. So I'm American. I like the movie Field of Dreams from 1989. It's about American baseball. It's a sport you guys don't know or understand. It's super boring to watch. It's like me watching cricket. But there was a movie by Kevin Costner in 1989 called Field of Dreams. And the whole premise was, it's really good analog for geothermal. It was this crazy guy who was a farmer, and he just wanted to build a baseball field in his cornfield. And he believed that if he built this baseball field in the middle of nowhere, all these great baseball players would show up. So the whole thing was, if you build it, they will come. And it sounds great. Who wouldn't want to go and get low carbon renewable heat from a geothermal plant in Northern Ireland. You would stimulate investment, and you will stimulate investment. The problem is the investors, they don't like this movie, and they don't want to hear anything about if you build it, they will come. They want to know that they can sell the heat from day one. So it becomes a bit of a chicken and an egg situation when it comes to the end user. From the investor's perspective, they need to know who you are going to be selling it to. But the actual reality is that if you do build it, they will come. And I've talked to geothermal producers around the world, and once they have the plant, they get people to come and use the plant if it's not hooked up to something. Dr. Ryan Law in Cornwall, I'll talk a little bit about it. He developed an electricity plant. He has a really unique story. He's going to give a talk to this forum, I think, next month. But really, what he told me is that, and I've known him for years, he used to work at Arup. Once he was in a real position of actually seriously developing this, having money for the wells in place, he basically got in a position where he had to choose and had to have real meaningful conversations about who he would sell the residual heat to from his electricity plant. So people will get excited about a geothermal project. You will start to see people being interested to develop their own industry around the availability of geothermal heat. But investors, they don't really like that. They want you to have a heat user in place. So this chicken and eggs fiasco has to be sorted out as part of your project development plan. And you need a strategy to prove to investors that you can sell the heat before they take it seriously to the point of giving you cash. The next bit is the financial model, and it will be scrutinized. And it will be scrutinized by somebody like me or other technical due diligence folks. There's lots of technical due diligence folks out there that love to say they know enough about geothermal to be dangerous. And every consulting firm would say they can do it. And there's companies like Geothermics that have been doing it for decades and decades. But your financial model will be scrutinized. And what it will be scrutinized on is are you taking risk seriously in your financial projections? So do you have a reasonable success rate for your drilling? Do you have a reasonable well yield? Do you allow for the decline in your reservoir and your actual wells? How are you managing the decline in your wells? Are you including workovers? Are you including makeup wells? In these small, low enthalpy projects, we don't typically have makeup wells. So it's well workovers and having the wells in place for the full life of the project, the full financial life of the project. How have you managed the plant availability and outages and your assumptions about those? And are those reasonable? And do you have good justifications for that? Now you churn all of that into your financial model. Are you going to be able to make money and pay back your investors in the amount of time that they want? And if not, how are you going to deal with that? That happens a lot in initial early stage geothermal markets. And so that's where we get into this whole business about government investment. And that's why we said in our study to the UK and for REA, look, if we can create a scenario where the price of heat can be advantageous to the developer and that can be secured with the government, then this whole business of the financial model is easier to demonstrate. And we get over part of the problem of Kevin Costner's Field of Dreams movie, and if you build it, they will come. Because now we at least have established a cost. And now we can tell the end user something about what it will take and what their participation in that project will. And it makes everybody is a little bit less nervous about what's going to happen when the plant is turned on from the perspective of how much money is it going to cost to produce heat and what's the revenue stream going to be looking like, what the government is going to provide in that revenue stream, and what the end user has to provide to buy the heat. So that's the government investment part. And you can see this is a giant puzzle piece. And Northern Ireland is still dealing with the puzzle pieces, much like the rest of the UK is. So where's the glue for all of this? And the glue is the champion. Because what you need is somebody for your project that is going to take you over the finish line and spend a decade just living with all of these crazy problems that they need to understand the geology, which is the fun part, but they need to be able to deal with the rest. And who knows what's going to come up in the rest of it. And I show two champions on here that I've worked with for a long time. Ryan, who's down in Cornwall developing the United Downs project, and Marieka, who works for Johnson & Johnson, Janssen Pharmaceutical in Belgium. And both these people have dealt with a lot of crap over the life of their projects to see it to the finish line. And they both have two wells in the ground that can produce energy now. Ryan can produce electricity, and Marieka can produce heat for her plant that will serve, the pharmaceutical plant that developed one of the COVID vaccines. I mean, what a great story that is at the end of it, you know. But they ran the marathon to get there, and so projects need champions. I'm a consultant. I work really hard. I worked really hard for both of these folks and continue to do so, but I'm not the champion. I have other commercial drivers that I have to live with as a consultant. You need the person that is part of the project, that lives with the project and sees it through. And Marieka didn't start the project. She inherited it, but she is not a geothermal person. She's a project manager, but she is the champion. She inherited from the heat plant person who moved on after he took it as far as he could. But it was really Marieka who saw this thing to the finish line for the Janssen plant. So I'll talk about a couple of last things, and then I'm pretty much done with my talk. And this is one of my favorite sentences that I hear all the time is, my project is totally drill ready. And that is something that project developers will tell investors all the time. Like, you don't want to go to that site. That site's not drill ready. My site is drill ready. And so what does that actually mean? Because that's what I have to wade through when an investor asks me, well, I like this one because it's drill ready. And so what does that actually mean? Do they have a drilling contract? Do they even have a well design? Have they even done a resource assessment for the site yet? Have they considered all of the planning obstacles they have to go through? Have they done a seismic hazard assessment? You live in Europe, you will be doing a seismic hazard assessment. Regardless of Brexit, you will still be doing a seismic hazard assessment for your project. You'll still be doing an environmental and social impact assessment. You'll still be needing to get planning, and you'll need to have your local community on board. Geothermal is an easy story for the local community, but you can still mess it up. There's a place called Basel, Switzerland that messed it up big time. And now Switzerland doesn't like to do geothermal. So you got to take that stuff seriously. Do you have the land agreements in place? Do you have a heat sale agreement? What other funding is in place? And do you have the people ready to go? These are the things that make a project actually drill ready. And if you're not actually drill ready, I guess it's fine to tell investors that you're drill ready, but be factual about what you actually mean by drill ready, because there will be somebody that will come interrogate it. And it can cause projects to slow down quite a bit when the wool is pulled away and people see the level of where the project is. And when we talk about investment, there are people that invest over here. There are the Kevin Costners of the world that want to cut down a cornfield and put in a baseball field. Banks will be over here, but you will get people that want to invest that are just hungry to do something with their cash that has an impact on stimulating a market like geothermal. They want to do it because in Finland, we had a petrol company, and the Elon Musk of Finland, we call him, and he wanted to drill 6.5 kilometer deep wells in Finland for heat. I mean, people said he was crazy. Still did it, and they still got 2 holes in the ground that go that deep in Finland now. So there are people that will develop higher risk projects. They'll want a little bit more of the pie in terms of the return on investment, but they're willing to take the risk. So you have to have a serious and reasonable financial plan that tells them what the risk is clearly. Last bit is my lessons learned, and then we're happy to take some. I'm happy to take questions after that. But basically, some things that I have learned and I see in my years of doing this type of work. There's two. There's the joke. You get 5 geologists, you get 5 different answers. That's a great joke, and it's real. You will get 5 different answers. In my team, I've got everybody's a geologist in my team, and we all have different answers. And I have to ask all of them before I tell my client, so that I at least make sure I don't miss something, because I'm the client, the guy that talks to the client. So I'm just trying to make the client happy. But listen to the geologists that have actually done this, because there's a lot of geologists that get excited about it, but the ones that have done it are the ones that will have been burned by it possibly in the past, and will be able to tell you a little bit more factually what you need to know, and how, and what tests you really need to do early on. What sort of geophysics will be useful? The resource assessment is never finished. You'll never finish the resource assessment. It's what makes us success. That's why we want to work on these projects in the first place. That's the most fun part. But you'll start, you'll get some information, you'll drill a well, you'll start to produce on that well, you'll start to see how the well field behaves, and your resource assessment will iterate always. And just expect it, and that's okay. It's part of the project life, is to manage the resource and to change how you operate it based on how it responds. Now, how it changes will get less and less as you move through your process, but it will continually be iterative. Be flexible about what you're expecting out of your project. You're probably going to get heat. You might want electricity, but you're probably going to get heat. Where you put that well is very, very critical. Listen to the geologists and the well designers about where to put it. It may not be the most convenient place on your site to stick it, but there's some very good reasons why they want to put it where they want to put it. And there is a real marriage between the best place to stick the top of the well and where it needs to go down in the ground when it starts to get curved. And there will be problems drilling. When I went to the Janssen kickoff, they had gone 500 meters into the ground, and they were so excited. They were like, we've got 500 meters into the ground. We're a third of the way down, and we've got no problems. There's not been any problems drilling. I'm like, you've done the easy part, okay? You've got a kilometer left, and that's going to be the hard part. So there will be problems drilling, and expect them and plan them and program for them and have costs set aside to deal with them. The plant's not going to be designed until you put those wells in the ground. You won't know what you're going to get until you get that hole in the ground. And there's no point in really putting a lot of focus on plant design until you get to that point. You got to put something in your financial model, and you have to have an expectation, but that's really as far as you need to go until you really have a hole in the ground. Public acceptance is critical. If you don't believe me, go and research the word Basel and geothermal, and then you'll understand it. And then go and research Landau and geothermal, and then you'll see a little bit more about how important public acceptance is. The folks in Cornwall, they've done a fabulous job in transparent communication. They put seismometers in schools to show the kids how this stuff all works together. They've created a great model. Geoscience, the engineering company in Cornwall, has done a great job with transparent communication. You're definitely going to need a seismic hazard assessment, and you'll definitely need some seismic monitoring. Risks are unavoidable in developing geothermal projects. That's why That's why we like it. And it will take time, and you'll need a champion. So that's it. That's what I've put together for this. I hope it's been helpful. I hope it will stimulate you to think about geothermal and get you excited about geothermal. And that's we're ready for I'm ready for questions or